Have you ever wondered how the iPhone 7 boot circuit works? This intricate system is the unsung hero that brings your device to life every time you press the power button. The boot circuit, also known as the logic board trigger circuit, is necessary for turning on the phone. It ensures that the power supply, clock signal, and reset signal are all in place. It also enables the CPU to carry out power-on self-tests and import the boot strap. Now let's get to know the main components of the iPhone 7's boot circuit. First on the list is the CPU. It wakes up other components related to the boot process, initiates power-on self-tests, imports the boot strap, and serves as the overall controller of the phone. Next up, the Power Management Unit, or PMU, provides power for the boot circuit to function. The NAND flash chip stores data needed for the boot process, like system drivers. The charging IC converts battery power into the main power supply. The battery connector enables the connection between the battery and the logic board. Lastly, the voltage converting IC changes the VDD_main, which ranges from 3 to 3.4 volts, into a steady 3.4 volts to extend the phone's battery life. Let's take a closer look at the NAND flash chip, a crucial component of the iPhone 7's boot circuit. This tiny chip is more than just a storage device. It's a powerhouse of data and an integral part of the boot process. The NAND flash chip is a type of non-volatile storage technology that does not require power to retain data. This means that even when your phone is switched off, the data stored in the NAND flash chip remains safe and secure. But what kind of data does the NAND flash chip store? Well, it's where the iPhone's operating system and other important files are stored. This includes system drivers, which are required to start the boot process. Without these drivers, the phone wouldn't be able to communicate with its hardware, making it impossible to boot up. So, the NAND flash chip doesn't just store data. It holds the essential information that your phone needs to start up and function properly. So the NAND flash chip is not just a storage device, but a vital part of the boot process. Without it, your iPhone 7 wouldn't be able to start up at all. So the next time you switch on your phone, remember the tiny NAND flash chip working behind the scenes, holding all the essential data your phone needs to boot up and function properly. Now that we're here, let's delve into precisely how the boot circuit of the phone operates. When the phone starts its booting up process, power is drawn from the phone's battery. This is the battery that keeps our device running, the heart and life force of the phone. It gives power to different components, essentially powering the entire process. Now, where does this power go? It travels all the way to two key components, the power MOSFET and the charging IC. So, what is the power MOSFET, you might wonder? Well, the power MOSFET, or metal oxide semiconductor field effect transistor, is a critical component to manage the power within the device. It's the gatekeeper of power, ensuring all components get the necessary energy to perform their functions. And the charging IC, on the other hand, is an integrated circuit designed specifically to manage the energy from the battery and control the charging process. These two are pivotal players in the power management of phone, ensuring power distribution is optimized and efficient. Now, as the phone continues to boot up, the power MOSFET and charging IC begin their dance. If the battery voltage falls within the boot process requirements, which, to be precise, is between 3 to 4.3 volts, the charging IC plays its part. It sends a low voltage to the power MOSFET. This is a crucial action in the boot process. It is what completes the breakover process, and the voltage begins its transformation into the main power supply. This main power supply is a significant component, quite literally the lifeblood of the device. It's then integrated and sent onward to the PMU, the Power Management Unit. The PMU is the brain of the power management system, making sure that every part of the phone receives the exact amount of power it needs to function optimally. Now, the PMU a check. If the received voltage falls between 3 to 3.4 volts, it sends a boost-enabled signal. This signal is sent to yet another critical component, the voltage converting IC. The voltage converting IC, an integrated circuit responsible for voltage conversion alongside an inductor, forms a boost circuit. It's worth noting that an inductor is an electronic component that stores energy in a magnetic field when electric current flows through it. The boost circuit that the voltage converting IC and the inductor form together converts the main power supply into a boosted voltage. This boosted voltage, full of power and potential, is then sent back to the PMU. But what if the received voltage is already between 3.4 to 4.3 volts? Well, the voltage converting IC has a solution for that too. It directly sends the main power supply voltage as the boosted voltage to the PMU. Pretty nifty, right? With the main power supply and boosted voltage in place, the PMU starts to generate the necessary power supply. The PMU is not just a receiver, but a generator too. It a voltage that activates the 768K clock when the power button is pressed. This clock is the timekeeper for the device, a ticking heart beating in tune with the electronic pulse of the phone. This action results in the boot trigger signal, a call to arms for the PMU. It prompts the PMU to generate not one, but a whopping 16 rails of power supply voltage. Among these, 14 are for the CPU, the central processing unit, the brain of the device. These include the core power supply for the CPU, an essential power line that keeps the brain of the phone running smoothly. Then there's the power supply for the CPU image processor, dedicated to rendering images on the screen. Another core power supply for the CPU is included, along with the power supply for SDRAM, or synchronous dynamic random access memory, which stores the data device needs to function. And lastly, there's the system power supply, the power line that the entire system, ensuring each and every component of the phone has the energy it needs to carry out its functions. And thus, with the main power supply and boosted voltage in place, the PMU starts to generate the necessary power supply. It generates a voltage that activates the 768K clock when the power button is pressed. This action results in the boot trigger signal, which prompts the PMU to generate 16 rails of power supply voltage. Among these, 14 are for the CPU. They include the core power supply for the CPU, the power supply for the CPU image processor, another core power supply for the CPU, the power supply for SDRAM, and the system power supply. To sum up, the iPhone 7 boot circuit is a complex system that controls the power supply, boot process, and overall functioning of your device. It's a symphony of components working together, ensuring that your phone powers up smoothly and efficiently each time. So the next time you press that power button, remember the intricate dance of components that makes it all possible.